know what the carbon dioxide is doing in the subsurface. Fortunately for us, the oil and gas industry has exactly the same problem with their reservoirs, knowing what's happening deep underground. And they've come up with lots of really smart solutions to this problem. One of the most important techniques is known as seismic imaging. In this method, sound waves are sent deep underground, and the echoes that come back are recorded and processed to give an image of the subsurface. The oil companies use this to look for traps that will hold oil and gas. We can use it to track carbon dioxide in the subsurface so we know what's going on. This example of a seismic image shows a vertical cross-section through a reservoir into which more than 10 million tonnes of carbon dioxide have been injected. The top of the reservoir is at about 800 metres depth. Here we can see the underground rock layers running more or less horizontally across the image. The bright colours are the carbon dioxide, which has been injected into the reservoir and has risen buoyantly upwards to the top of the reservoir to come to rest against the seal rock. Importantly, there is no sign of any carbon dioxide within the seal rocks or in the overlying rocks, so all the injected carbon dioxide is trapped within the reservoir, which is obviously good. Seismic images are expensive, unfortunately, so other methods are being developed to enable us to monitor the carbon dioxide in the deep surface. One method is to monitor the strength of the Earth's gravitational field. Because we're injecting relatively low density carbon dioxide, which displaces relatively high density water, we get tiny changes which we can detect at the surface using very sensitive equipment. We can then compare our measurements to predictions of what we expect to happen. If the measurements and the predictions are pretty much the same, then that's good. We can be confident that things are happening as we expected. If there's a significant difference, then clearly we have to start to investigate. There are other monitoring methods that allow us to work out what's happening to the carbon dioxide in the underground. One of these, especially if we have convenient water wells in the vicinity, is to take regular samples of water from the subsurface and analyse it for carbon dioxide. For this method to work, we really need to know what the composition of the groundwaters are before we start injecting. It's been found by studying groundwaters that many of them have annual variations in their composition. So the summer and the winter will show significant variation. What this means is that we need at least 1, maybe 2 or more years of data before we begin injection. This data is known as baseline data, and it's essential for any successful monitoring campaign. If we get leakage of carbon dioxide from the reservoir, what can we do about it? Fortunately, again, we can turn to the oil industry for experience, and we have plenty of techniques to choose from.